Hi, good afternoon. And it is afternoon now. Are you all enjoying ADC? Yeah. Really are being enthusiastic today. Must be a good conference. All right, I'm going to talk about software security. So we're going to pivot slightly from diving into pure audio, and we're going to look at how we protect those algorithms, protect everything we're building. So I'm going to talk about software security. We're going to define what it is. We're going to define why it's important. And we're going to look at some of the latest advances within software security and what they mean to you. I'm Neal Michie. I'm VP of Product Management at PACE Anti-Piracy. With me today, we have Bob Brown, who heads up our client engineering team. And we have Ryan Wardell, who looks after our QA, support, and program management. They're here to keep me right, make sure I don't say anything that's going to get me or the company in trouble. Now, you may know PACE best as the iLok company. And in many cases, that is true. We provide the iLok, it's who we are. And why wouldn't you know us as the iLok company? This year, we've crossed over distributing over 300 million licenses to over 13 million users. So it's an incredible kind of base to build from. But PACE is much more than just iLok. Within the PACE brands, as well as iLok, we have JUCE, the framework I'm sure you all know very, very well. And we have ADC, this conference where PACE is a custodian of. And it's been a big year at PACE. We've had 4 massive anniversaries. PACE itself is 40. iLok is 25. Who'd believe it? 25 years of iLok. JUCE is 20. And this conference, this is the 10th anniversary of ADC. 11, if you include the JUCE summit that kicked it all off. But PACE, at its heart, is a software security company. That's kind of what drives us, what we're really passionate about, is protecting software, protecting IP. And when you look at iLok, the reason iLok licensing can stay robust in the field is because it's underpinned by strong software security. And that's why PACE, at its core, has to be a software security company. A software security company that loves all things audio. And one of the things that struck me when I started at PACE was just how culturally similar the mindset is to creating software security than it is to creating audio. So it's amazing how the two fit so nicely together. So why is software security so important? Well, I think it's good to start to think in the mindset of the hackers, of the threat actors, the bad guys that are coming after your software. And I like to use the analogy that software is a book. And most people think of it as being a book that's kind of one of these teenage diaries that has a little lock on it and you can't open it. And it's not a bad analogy because actually it's really easy to open, even with a little lock on it. It's really easy to open. And really, software is more like a book on a bookshelf in a trendy coffee shop. Anyone can walk in, take it off the shelf, open the book, and start reading the pages. And that's exactly how a hacker begins when they start looking at software. They take the binary, they open it in a hex editor, they open it in off-the-shelf analysis tools and start to see that code in front of them. Looking for something interesting, a clue to how the software works, how the special algorithm that you spent years developing, how that behaves, secrets within the code like an API key, and don't have to Google far to find examples of API keys that have been leaked from code because they were hard-coded, or cryptographic keys that are used within the software. It's all there, ready to be read. So the hacker opens the book, starts reading the pages, but they want to go further. They want to see the movie of the book play out on the big screen in front of them. So they attach debuggers, they attach hooking frameworks to the software, so they can see how it's behaving dynamically, how it's running, what it's doing. And they actually want to go one step further. They want to play the interactive virtual reality video game of the book. They want to prod and poke at it, see how it happens as they change things, manipulate things. If I push here, oh, this thing pings over here. How's that connected? Kind of dig into it, see where it's going. Hit a security block, just remove it. Just like shooting the bad guy in the game. Take it out, get it out the way. So this is the sort of skill level that hackers have. And what's quite incredible is a lot of the tools to do this are available just from downloading. You don't have to look far in your favorite search engine or AI chatbot to find the tools to do this, to find code, to find instructions on what to do. There's even university courses on this stuff now. So, as I say, PACE needs to have this mindset of how do we stop against these sophisticated, highly skilled attackers. And we underpin iLok, we underpin a lot of what we do with software security developer tools. The first of which is called WhiteBoxWorks. And it's a white box cryptography product. White box cryptography was originally developed to protect cryptographic algorithms and cryptographic keys within software. And PACE has extended the concept with our third generation white box so that we can protect any algorithm and any data that that algorithm is working on. What makes kind of white box different from more generic code protection is that it focuses on treating code and data almost as one and the same, interchangeable, and manipulates them and twists them together so that an attacker can't get in, can't see what's going on, and then builds very targeted countermeasures on top of that. So proven in markets like mobile payments, kind of very strong security requirements, very kind of aggressive attackers. Money is at stake here. Kind of white box gives really strong protection when you've got something that you want to target within your code. So an algorithm, a piece of data, cryptographic key, that's very sensitive. We complement WhiteBoxWorks with our second developer tool, which is called Fusion. And Fusion is designed to protect a whole software package. So it's got to be very efficient, it's got to be optimized, so not to damage the performance of that package. If you've got an audio algorithm that's running in a tight loop, it's got to continue to be performant. We can't damage that. It's got to be predictable as well. We can't have spikes in the tracing, etc. So Fusion works within those constraints, but provides very strong security across the whole software package. Whether that's a binary executable, whether it's a dynamic library, whether it's an audio plugin, across them all. And it uses technologies like obfuscation, which I'm sure you're all familiar of, but not kind of superficial obfuscation you get with a lot of open source products, but very deep control flow obfuscation that goes into the actual workings of the code. We provide runtime protection. So remember I said the attackers want to prod and poke at your thing, watch it running in the big screen. So we provide runtime protection so you can't attach a debugger to the software in the first place. And then we bind it all together with anti-tamper. An anti-tamper is there to make sure the software that's executing is exactly the same as the software that was published, that left the developer's machine. So it's a giant spot the difference. It makes sure that what's running is the same as what it should be. Hasn't been manipulated, hasn't been changed, hasn't had a security feature removed, hasn't taken your algorithm and plugged it into another piece of software. So Fusion, as I say, code hardening for native software, obfuscation, anti-tamper, runtime protection. And we've been working on the next generation of Fusion, which is soon to be released. And with the next generation, we're looking to make sure that we provide easy integration. So if you're developing or kind of using as your build system, CMake, Xcode, Visual Studio, Producer, and if we have really simple off-the-shelf integrations that just plug in to what you're doing. We're going to make sure you have fast build times, so your development cycles are not interrupted by our tooling. It just sits in the background, gets on with it, and you can code, build, test, repeat, just as you do today. We're going to have low-touch tuning of the protection. Kind of performance is so important to the software that you're building, and what we're doing should not get in the way of that. So it needs to be tuned, it needs to be balanced to what you're building, your use cases. But typically, the customers we work with don't want to spend time doing this. This takes away from normal development cycles. So with low-touch tuning, let the intelligence of the tools handle that, and let you get back to the fun stuff of writing functional code. In saying all that, security is important, and we do want to make sure that we get a high density of security. High density security equals better security, typically, into the software. So all this put together creates something that should give very high level of security, but allow you to develop and work as normal without us getting in the way, kind of fitting in with modern development cycles. And when you look at the developer workflow that we'll bring with Fusion 6, which is the next version, it's basically how you work today. Kind of, it's a developer tool, so you're going to have to download, install it, that little simple integration into your build system, and then, all going well, we melt into the background. And you can go through your standard code, build, test, repeat cycle until you're happy and you publish your software. And yes, you'll be able to configure the tools kind of to your needs. You'll be able to turn off protection if you want to kind of test a particular feature or do some debugging, but kind of as standard, we're just part of that process and running through nicely. If you do need to tune it, then you can enable the tuning features, and that opens up this flow which runs in the background. And we tune by profiling the software. We want to understand how your software runs on real devices under real use cases. By knowing that performance profile, knowing how it's working, how it's operating, allows us to provide protection in ways that doesn't impact on the performance, because we know where it's going to. We know where the problems are going to be. So we have this flow when you enable tuning. When you enable tuning, we then gather what we call dynamic analysis data, but just profiling data, how your software is running. That tuning data feeds back into the tools, and the inbuilt intelligence within the tools can use that data to then apply the protection in a way that doesn't damage performance. Once you're happy, turn that off, lock down the tuning, and it's all good. It will stay performant. So through that process, the tools auto-tune the performance for what you need. And what we're effectively trying to do is balance the impossible. Balance security and performance and optimize for both. And with the data, with intelligence and the tools, we go a long way towards that. Right, I want to pivot slightly into something we launched a couple of months ago. New product, which is called Fusion AI. Fusion AI is there to protect embedded AI models. By embedded, we mean models that are included as part of a software application. The model code, the weights and the data structures, etc., are actually part of the application that's being deployed out in the wild. There's no cloud service, everything is local. You do this, it's very appealing in many use cases, because you do this for low latency. There's no data connection back and forth to the cloud. Everything is local. It's privacy preserving. You're not sharing data with anyone else, so there's no risk of it leaking from your cloud because it never gets to your cloud. And the other advantage is no cloud. There's no cloud costs. All the processing is done on your end users' machines. So running models locally within, sometimes called at the edge, is very, very appealing in many markets and for many reasons, including the audio space. The trouble or the challenge when you put models at the edge is they're now in their most vulnerable state. You've spent weeks, months, years developing, tuning this model, getting it just right. And then you deploy it and someone goes, that's nice, I love that, and runs off with it. That's not where you want to be. Software is at its most vulnerable, and this is where you're putting your most sensitive IP. It becomes easy to steal the IP, becomes easy to analyze, and becomes easy to manipulate. So with Fusion AI, we took PACE's toolings, the flexibility of that tooling, and built purpose-built protection around embedded AI models. Taking those tools, allowing them to slot nicely into the ecosystem, into the runtimes to minimize any gaps that an attacker could get into, and keep those models safe, keep them secure. Let me walk through that and show you kind of what it means in practice. So this isn't my flow, this is one that one of our developers gave me, but kind of a typical approach when you're deploying embedded AI. You architect the model, you train it, convert the model into a format that's embeddable into your software, make sure it's optimized, then you deploy the model at the edge, and then use that model. Great, it works. Being a security guy, my aim is to make sure not only that this model works, but that it works safely and securely when at the edge and embedded in the software application. So if we start and follow the documentation, if you look at kind of the runtimes for these models, a lot of them have versions for embedding into software. And if you follow the documentation, it says, put the model in the file system beside your application, read it from the file system, use it. And it shows you nice worked examples on how to do that. If that file's on the file system, copy, paste into email, send. I've stolen the model. It's not exactly secure sitting there. And by the way, the model may look like a lockbox like your software, but it's just a zip file. And that zip file is the weights, the architecture, everything around that model. Nothing very, very hard to analyze at all. So if we follow our docs, kind of someone is literally going to drag your model away and it's gone. So we need to step things up. So this is why I called it option 0. There's 0 security. So option 1, we want to be a bit more secure. We realize having the model as a file is a bad idea. So we go, I know, software is a lockbox. I will embed the file inside that software binary. Great. Run a few scripts, get the model that is in the binary, read the model from the binary itself rather than from the file system. That's all very well, but as you probably gathered, I don't think of software as a lockbox. I know that this model can still be easily extracted. And remember, it's just a zip file. If I open the binary in the hex editor, search for the first couple of bytes that every zip file starts with, I very quickly, as we're showing here on the screen, can find that model in the file. Use nothing more than the hex editor, and I'd be able to copy out that data. So option 1 is a bit better, but it only gets us as far as a hex editor in terms of protection. So what do? We need to stop someone reading this model. Standard approach, we encrypt it. Encryption is good for stopping people reading things. So we're going to take the same data, we're going to encrypt it, nice AES 256, something like that, encrypt it, and then we'll have our code decrypt the model at runtime when it's being used. That's good. Seems good. If we open our binary in a hex editor now, we can't find any sign of the zip file. We can't find any sign of the internal contents of the zip file. So, yeah, it's probably better. Now, if you remember earlier when I was talking about some of the risks, and cryptographic keys are quite easy to find in software. So we open up the binary, cheating slightly here, but we search for the cryptographic key within the binary. So that's the key, and there's the key sitting in the binary. Even in the, okay, we're searching for the exact thing we're looking for, but even if we're don't know exactly what it is, it's still going to be relatively easy to find this is a key in the binary, and then take the key, decrypt the data, we're back to where we started. And even if you were to do something like over-the-air deploy the key for decryption, we can still watch the software running, we can still monitor what's happening. By doing that, we can still get access to the cryptographic key. We're back where we started. So standard encryption algorithms are not very good for keeping keys safe within the software. Good for protecting data at rest. As soon as you move into any sort of runtime, it's going to be problematic. So this is where PACE's products start to come in. Let's move that decryption step inside a white box. Remember, one of the primary use cases, initial use case of white box cryptography was to protect cryptographic operations. If we do that, then even if the attacker knows the key, doesn't know anything about the key, they're not going to find the key. It's not going to be there to be found, even when the algorithm is running. And even if they know the algorithm, it's not going to help them. It's all within this white box environment where you can't see it, what it's doing when you analyze it statically, reading the book, and you can't see what's happening when the software's running. It's still in a state that's not interpretable, not understandable. Even if you see every instruction execute, every memory read, every memory write, you're still not going to find this key because it's never there and it's in a form that's useful. So, great, we've got our AI model is now encrypted, it's locked down, and the means to decrypt it are not going to be findable, not going to be discoverable within the code. And our final step, option 4, is let's just make sure it's all locked down, it's all bound, and an attacker's not going to be able to look at this model when it's at runtime, when it's executing. And that's where the Fusion product I spoke about comes in. We bind everything together, turn that software back into that locked box, that locked book that everyone thought it was at the beginning, and it turned out it wasn't. So we lock it all down, bind it together, combine with white box, the whole thing is going to keep that model safe. It's no longer going to be possible to inspect it, it's not going to be possible to manipulate it, and it's not going to be possible to steal it. I call that success. We have protected our model. And I'll leave you with one final view. So this is a tool called Insight, which we use internally to understand software that we're protecting. So remember I said one of the key things we try and do with all our products is to make sure that while we're offering very strong security, we're also offering very strong performance of the products we're protecting. We're not impacting all that hard work you do to optimize your algorithms. So to get to that, we need to understand how software is put together, how it's constructed, and we need to understand how our protection is applied into that software. And in the middle of the screen, this graph here is the performance profile. And most performance profiles look much like that, where you have some code that's error paths, kind of not executed very often. It's there for corner cases. Kind of that's great. Kind of, if we add much in there, we're just going to blow up the software. And then at the other end, big spike, red spike that's going up, that's performance critical code. That's when there's no CPU overhead to add anything else. So we're looking for the sweet spot in the middle. Code that's run often, but there is still some space to add extra processing. So by understanding how software is put together, how it's constructed, we can add very strong security, but still be respectful of the performance profile. So all these different diagrams, different views, are different ways of looking at software, looking at how it's connected together, looking at how it all fits and how it works. And we couldn't get it to work, but it does make some cool noises as it spins around as well. But anyway, we couldn't quite get that to share. And that was me. So, thank you.